Here's some pieces about electron configuration. Some of this might be a review if we got this far. If we didn't get this far, as we did in year 2018, some of this will be new. Pay close attention to these slides. All right, so as you can see, we have electron configuration here. I wanted to remind you that as you look at the big numbers in front, the 1, 2, 2, 3, 3, 4, 3 in this example, those are the energy levels. The letters, S's and P's and D's, and if there was any F's, those are the sublevels or orbitals. And then the superscript number is the number of electrons. How many orbitals are in a D sublevel? Remember that the sublevels have the same number of orbitals as they do like we colored on the periodic table. So there are 5 D's, sublevels, or I could call this word orbital. I can interchange the word sublevel or orbital. There is 1 S sublevel. There are 3 P sublevels or orbitals. And there are 7 F sublevel or orbitals. How many electrons are possible? If you remember, if there are 2 orbitals, and every orbital can hold up to 2 electrons, then this has 2 electrons, and F, remember, having 7 orbitals, has 14 electrons. A D, having 5 sublevels or orbitals, has 10 max electrons, and a P that has 3 orbitals or sublevels can have 6 electrons. So remember that every orbital or sublevel contains up to 2 electrons. All right, an example here. How many electrons containing orbitals are in silicon, for example? You would want to write out the arrow diagramming and then count how many orbitals, aka dashes, have electrons in them. This would be 1, 2, 3, 4, 5, 6, 7, 8. So you would say 8 orbitals. Here are the answers for these other examples. Try those if you wish. Next kind of question. What is the highest energy level for cadmium? You'll write electron configuration out. You'll look for your highest energy level. 5 is my highest energy. Remember, the number in front is the energy level. These are the answers for these if you'd like to try. How many completely filled orbitals are in an atom of silicon? Again, write your arrow diagramming out and figure out how many completely filled orbitals are in an atom of silicon. This is filled, so 1, 2, 3, 4, 5, 6. 6 is the answer. These are not filled. This is half filled, and this one's empty. Here are some for you to try. Next type of question. How many electrons can be obtained in all the orbitals related to arsenic's 3rd energy level? So I write out configuration for arsenic. I find electrons that arsenic has in the 3rd energy level, so these 2 and these 6, these 2, these 6, that's 8, and these 10 is 18. Let me do that again. It says 3rd energy level right here, so I'm doing 3. So I see 2 here from this 3s2, I see 6 from 3p6, and I see 10 from 3d10. That gets me a total of 18. Try these. What is the maximum number of electrons in the 3rd energy level? All right, so here's what you want to do that. You think about, well, are there any S's in that energy level? Yeah, there are 3 S's, and there's 2 there. Are there any P's that are in the 3rd energy level? Yep, 3p6 exist. Are there any D's in the 3rd energy level? Yep, 3d10, but there are no 3 F's. So we'd add 10 plus 6 plus 2 and get 18. Try these. Here are some other things you could try for the review. You may have to pause to get through them.